66 million years ago, on what was probably an ordinary afternoon, the single worst day in the history of complex life on Earth began. Not a bad week, not a rough century. One afternoon, and by the time the sun set, roughly 3/4 of all species on the planet were on an irreversible countdown to extinction, including every non-avian dinosaur that had ever ruled this planet for over 150 million years. You've heard the short version 100 times. An asteroid hit, the dinosaurs died. But that summary is doing an enormous amount of heavy lifting, because the actual sequence of events is far stranger, far more specific, and far more terrifying than big rock falls from sky. Let's start with the size of the thing, because your brain almost certainly isn't picturing it correctly. The asteroid, now known as the Chicxulub impactor, was roughly 6 miles wide. That doesn't sound especially dramatic until you realize it was traveling at somewhere between 40 and 50,000 miles per hour when it slammed into what is now the Yucatan Peninsula in Mexico. At that speed, the asteroid crossed the entire height of Mount Everest in about half a second. It didn't experience impact the way you'd imagine a rock landing. It hit the atmosphere and the ground almost simultaneously, converting an unthinkable amount of kinetic energy into heat and shockwave in a fraction of a second, releasing energy equivalent to billions of atomic bombs detonating at once. Here's the detail almost nobody talks about, and it's the detail that made this impact catastrophically worse than it needed to be: location. If that same asteroid had hit almost anywhere else on Earth, the outcome might have been survivable for far more species. But it hit a shallow sea shelf loaded with sulfur-rich rock, specifically gypsum and anhydrite deposits. When the impact vaporized that rock instantly, it didn't just create dust and debris. It launched an estimated hundreds of billions of tons of sulfur compounds directly into the upper atmosphere. This is the part that turned a bad day into a mass extinction event. Sulfur aerosols in the atmosphere are exceptionally good at blocking sunlight, and this impact essentially loaded a global sunlight-blocking weapon directly into the stratosphere in the first few minutes after collision. But before the sunlight blocking even started causing problems, the immediate aftermath was its own nightmare. The impact triggered earthquakes so powerful they registered at a magnitude scientists estimate at somewhere around 10 or 11, dwarfing anything in recorded human history. Within hours, massive tsunamis, some estimated to have reached heights of over a mile in the areas closest to impact, tore across ocean basins. And then there's the detail that sounds almost too cinematic to be real: the ejected material, the vaporized rock and asteroid debris thrown up into and beyond the atmosphere, began raining back down across the entire planet as superheated fragments. Scientists studying the geological record have found evidence suggesting that within hours of impact, the re-entry of this debris may have heated the atmosphere enough to essentially broil the surface of the Earth, potentially igniting wildfires across vast stretches of the planet simultaneously, thousands of miles from the impact site itself. So within the first day, you have earthquakes leveling structures across continents, tsunamis erasing coastlines, and what may have been a literal firestorm sweeping across forests on the opposite side of the planet from where the asteroid actually hit. And that's before the slow part even begins. The sulfur aerosols and soot from the global fires spread through the upper atmosphere over the following weeks and months. And this is where the extinction event stopped being an explosion and became something closer to a slow strangulation. Sunlight, the thing every single food chain on the planet ultimately depends on, was blocked to the point that scientists estimate photosynthesis may have been severely disrupted, possibly for years. Think about what that actually means moving down the food chain. Plants that rely on photosynthesis begin dying en masse. Herbivores that eat those plants start starving. Predators that eat those herbivores run out of food shortly after. This isn't a single catastrophic event killing everything at once. It's a countdown timer that started ticking the moment the sky went dark, and every level of the food chain had a different, shorter fuse. Temperatures dropped sharply in what researchers describe as a period resembling a brutal impact winter. And this is genuinely one of the most counterintuitive parts of the whole event. Before the cooling, the initial blast and re-entry heating likely caused a short period of extreme warming near the impact and possibly on a broader scale. Then, as sunlight got choked off globally, temperatures crashed, potentially by tens of degrees, for months or years afterward. Species had to survive an almost impossible 1-2 punch. Extreme heat, followed by extreme prolonged cold, followed by a collapsing food web, all within the same general stretch of time. So why exactly did the dinosaurs, specifically the massive non-avian dinosaurs that had dominated Earth for over 100 million years, get hit so much harder than other groups? Body size seems to have mattered enormously, and not in the direction you'd expect from a creature built to dominate. Large animals generally need significantly more food to survive, and in a world where plant life was collapsing and the food chain was contracting from the bottom up, being enormous stopped being an advantage and became a liability almost overnight. Smaller animals, including small mammals, some birds, and various reptiles, could survive on far less food, could shelter more easily, could reproduce faster to rebound from population crashes, and critically, some had dietary flexibility that let them scavenge, eat insects, or eat decaying organic matter when fresh plant and animal food sources vanished. This is actually the key to one of the most interesting surviving lineages: birds. Birds are, technically and scientifically, dinosaurs. They're the direct descendants of a specific branch of theropod dinosaurs, and their survival wasn't luck so much as it was a combination of small body size, the ability to fly to find scattered remaining food sources, and in many surviving lineages, beaks adapted for eating seeds, which turned out to be one of the few food sources that could survive in a dormant state through years of catastrophic darkness and cold. While massive dinosaurs were starving because there was nothing left to eat, small seed-eating dino descendants were quite literally living off of nature's own long-term food storage system. Marine life took its own devastating hit through a related mechanism. The base of oceanic food chains, phytoplankton, also depends on sunlight for photosynthesis, and when that collapsed, it triggered its own cascading die-off, moving up through the ocean's food web, wiping out an enormous percentage of marine species, including many large marine reptiles that had thrived for tens of millions of years. What's remarkable, looking back at this entire sequence of events, is how many separate, almost unrelated catastrophes had to stack perfectly on top of each other to cause an extinction this complete. A slightly different impact angle, a slightly different location without that specific sulfur-rich rock, even a slightly different time of year, and the outcome for life on Earth might have looked completely different. Some researchers have pointed out that if the asteroid had struck the ocean rather than that specific shallow sulfur-rich shelf just minutes earlier or later in its orbital trajectory around the planet's rotation, the sulfur ejection might have been dramatically reduced, and the mass extinction might never have reached the scale it did. So the honest answer to what killed the dinosaurs isn't simply an asteroid. It's an almost impossibly specific chain of catastrophic bad luck. The exact size and speed of the impactor, the exact chemistry of the rock it happened to hit, the earthquakes and tsunamis and fires that followed within hours, and the years-long collapse of sunlight and food chains that followed after that. It's less a single moment of destruction and more a perfect storm of the worst possible conditions arriving in exactly the worst possible sequence, all triggered in the time it took a 6-mile-wide rock to cross the last few miles of sky. And somewhere in the wreckage of that impossibly bad day, a handful of small, flexible, seed-eating survivors kept going and eventually became every bird you've ever seen outside your window.